So a couple of other patterns that are important when we're expanding this is expand and simplify 3b minus 1 to the 4. And this exponent of 4 is going to tell us where in Pascal's triangle we should go to. Okay? The thing that I use probably the most, and if we just go back to what we did previously, the patterns that we noticed. Did you notice, and this is the one I will use, I'll pull up my highlighter here. This is the binomial expansion you're most familiar with because you have done a plus b squared the most of all of these things. Very rarely do you do something to the power of 1 because it's kind of pointless. But I want you to notice that when you expand that, you get 3 terms, which is 1 more than the exponent. When we did a plus b cubed, we got 4 terms. So in our example here, where we have 3b minus 1 to the 4, I see that 4. I know that I need 5 terms, and in Pascal's triangle, I look for the row with 5 numbers. So if I want to expand completely 3b minus 1 to the 4, I can start by writing out these numbers, space them out pretty well. 1, 4, 6, 4, 1. I know that those are going to be my coefficients. Now, if you think about actually writing this out, b minus 1 4 times. And the very first one is choosing all of the first one and none of the second one. Does it make sense that you would have, oh, I want to change to black. Three b's 4 times. Just like we had a to the 4, but now the first term has 2 things, put it in brackets. It's going to happen 4 times. And then in the second one, you'll have the 3b's 3 times and the minus 1 once. You could write a 1 there if you want, or you can leave that out. The third one, we're going to have 3b's 2 times and the minus 1 2 times. Then the 3b once. And the minus 1 3 times, and finally the minus 1 4 times. This is using the patterns that we noticed with Pascal's triangle and the patterns that we noticed with the exponents. So we have done this part, we've expanded it. We just have not simplified yet. Order of operations. What do you do first in order of operations? Brackets, then exponents. In the brackets right now are just holding numbers, so there's no math to do inside of brackets, but we do have exponents. So I would start expanding. And here, well, the 1 I don't even have to write, but 3 to the 4 is 81 b to the 4 plus 4. 3 cubed would be 27 b cubed, and still have a minus 1 plus 6. This will be 9b squared, and minus 1 squared will be positive 1 plus 4, and 3b minus 1 cubed will be minus 1 plus, and negative 1 to the 4 is positive 1 times 1 is 1. So I just did my exponents first. Sometimes you might be tempted to do more at once. That's perfectly fine. Just be careful, because whenever we try to do extra math at once, it's usually when we make our mental math errors. So now, what do I have? This one, there's nothing more to do. Here, I'm going to multiply my numbers together. 4 times 27 is 108 times a negative 1 is negative 108 b cubed. 6 times 9 times 1, that's 54 b squared. And then 4 times 3 minus 12 b, and then finally plus 1. This is our final answer, expanded and simplified. This is one type of binomial theorem question you'll get. Can you expand it completely? In other words, can you use Pascal's triangle to get the numbers, those blue numbers that we started with? Do you recognize the pattern that we saw in that the exponents, you always have the exponents adding up to 4? We started off with the 3b minus 1, 3b minus 1, 3b minus 1. You start off by choosing 0 minus 1s. You choose all the 3b's. There's only one way to do that. And then you would have 3b to the exponent 4, because you had those 4 times itself. Then each time your first variable goes down by 1 in exponent. Your second variable starts at 0 and then goes up 1, 2, 3, 4 in exponents. Recognizing that pattern is going to be very helpful. So one type of question is this, expanding it completely. Okay? Sometimes they'll ask questions, like I've seen multiple choice questions that say, hey, if you expanded 3b minus 1 to the 4th, how many terms would be positive? 1, 2, 3 of them are positive. 2 of them are negative. Does it make sense analyzing the minus 1 that you're only going to get negatives when that minus 1 has an odd exponent? So there's going to be questions where they're going to say, hey, you don't have to expand it completely. Just tell me how many of those terms are going to be positive, how many are going to be negative. And we can see that from this pattern. Okay. Circle questions 3 and 4.